Hi, this is the reaction of sugar lecture. It's going to be two parts. I'm going to focus on oxidation reduction and formation of ethers in this lecture. And then in the second hand, we'll discuss a little bit more complicated reaction of glycoside formation. All right. So monosaccharides behave as simple alcohols and carbonyls in much of their chemistry. So for example, aldehydes and aldose can be reduced to alcohols when it is subjected to a reducing agent, for example, sodium borohydride. All right, but as you can see, we know that now sugars, super monosaccharides, exist in solution in a cyclic form majority of times, but you know that under equilibrium there's a little bit of open chain available, and it exists in equilibrium. All right, so this is an example of D-glucose, and the reason why I don't have anything on the anomeric carbon C1 is because I have a mixture of alpha and beta D-glucose, well, glucopyranose to be totally correct. And instead of drawing two cyclic hemiacetals with one OH up and one OH down, a lot of times when you have that mixture, it's drawn with a squeaky line with an OH to indicate that you have both mixture of OH up and down at the anomeric carbon. So we have a mixture of the glucose, hemiacetal, and we're going to do a reduction, meaning that we're going to go from oxidation level 2 to 1 in this case. But notice in a cyclized form, there's no aldehyde, there's no carbonyl to reduce. So even with the sodium borohydride reducing agent, it's not going to reduce the cyclic form. But it will reduce as soon as this opens up to the lineal form. So here we have the aldehyde. That's when the sodium borohydride reduces. All right, and because there's an equilibrium going on, as soon as this gets reduced, so this is going to go from oxidation level 2 to oxidation level 1, so you're going to have an extra H and an OH, H and an OH, so that will be the product. So as soon as this forms, this can't cyclize anymore, so it's stuck in this open chain form. So then, since this is no longer there, once it gets reduced, more of this is going to open up to become this, to re-establish the equilibrium according to the Le Chatelier principle. Gets reduced, becomes this, and it keeps doing that until everything gets reduced. All right, so this right here is called D-glucitol. Notice the ol for the alcohol, and it's a naturally occurring compound found in many fruits, and it's also used as artificial sweetener under the name of D-sorbitol. And I think you've seen that in packages, all right? So if you draw this in a Fisher projection, you should have an extra H and an OH where the aldehyde used to be, and everything else should be exactly the same of the glucose. All right, so that is a reduction. All right, now let's go over oxidation. Oxidation is going to be going to a higher oxidation state. So in this case, it's going to go from oxidation state from 2 to 3. All right, now once again, under the cyclized form of the alpha and the beta D-glucopyranose, nothing's going to happen with an oxidizing agent. It has to open up to the open chain form before oxidation could occur, right? So your book uses Br2, bromine in water, as an oxidizing agent. So I'm going to go over the mild oxidizing agent first, and then a strong oxidizing agent, and I'll go over what the difference is. But some of the other ones that you'll hear is Tollens reagent, which you may use in the lab. A lot of times that's a test that's used to prove that there was an aldehyde present in the material that you're working with. And the other one that's often used is Benedict's. All right, so all these are mild oxidizing agents, which means that it's going to go from 2 to 3. So here's the aldehyde, which is at oxidation level 2, and with any one of these reagents, it's going to oxidize, and what happens to that N-amer carbon, which used to be an aldehyde, it now becomes carboxylic acid. All right, so now that's the oxidation level 3. All right, so if you draw it in this form, it's going to be CO2H at the top. All right, these type of sugars that are able to oxidize, the sugars that are able to be oxidized are called reducing sugars. And it's a term that you need to recognize and be able to use. So the definition of reducing sugars is sugars that give positive tests to above reagents. All right. So when the sugar gets oxidized, you know that when something gets oxidized, something has to be reduced. And what gets reduced are reagents in these oxidizing agents. So for example, in Tollens, you have a silver +1. That's the active ingredient. And as it gets oxidized, the sugar gets oxidized, this gets reduced to silver 0, which precipitates it out as a black precipitate, or silver mirror if you do it carefully. In Benedict's, it's copper +2, which gets reduced to copper +1, and it precipitates as cuprous oxide, which is a reddish precipitate, and that is an indication that that sugar was a reducing sugar because it's able to reduce the reducing agent. Okay, so the key is, as we talked about before, you have to have a hemiacetal sugar in order for it to open up, and so that it could be either oxidized or reduced. All right, if the sugar is in the acetal stage, in other words, you have OR group here, so not a hemiacetal but an acetal stage, these are not reducing sugars, and they're not going to be have any effect with sodium borohydride either. So in other words, acetals are more stable, they're not going to be able to open up, so it's stuck in the cyclic stage, so therefore it's going to be not a reducing sugar. All right, so this test actually is used, Benedict's test is used in lab and at home to see if there's any glucose in your urine. So that's one of the quick ways to test if you're diabetic or not, because if you are diabetic, you have a high level of glucose in your bloodstream or in your urine, and so they want to quickly be able to test that, and they have these sticks that you could buy, and they do this in a lab, doctor's office. So when you give a urine sample, they take out one of the sticks, which looks like this, and this last one is coated with an oxidizing agent, Benedict's, which is copper +2, which is green in the beginning, And then if there's glucose in your urine, when you dip this in, then this will get reduced to reddish color, right? And while the glucose gets oxidized to gluconic acid type of compound. So what you do is you basically look at the color difference to see how much, approximately how much glucose in milligram per deciliter concentration you have in your urine. And it says in there to read exactly at 30 seconds, so that's how quick the reaction is, and then you compare the color. All right. So this test is actually used in the lab, in clinical setting as well as in the lab, chemistry lab. All right. So the next type of oxidizing agent, what I call strong, is nitric acid with heat. So you're going to heat it with nitric acid. And once again, we're going to start with a mixture of alpha, beta, D-glucopyranose. And you have the open form here, open chain form, which now gets oxidized to carboxylic acid like before. But what happens is that under strong oxidizing agent, what it does is not only convert the aldehyde to the carboxylic acid, but it also converts the primary alcohol that's at the end to a carboxylic acid also. All right, so not the secondary alcohols, they don't get oxidized, but just the primary and the aldehyde. So what happens is when you draw this out, the last carbon, which used to be CH2OH, now is also an acid, as well as the aldehyde being an acid. So diacid is the product when you oxidize with a strong oxidizing agent. All right. So I'm almost basically running out of time here, so I'm going to stop here. And by the way, these diacids are called, for glucose anyway, D-glucaric acid. And then you should be now be able to do these problems, 24-24, 24-28, 24-31, 32, and 33. So try to attempt these, and if any of these questions are about the ethers, hold off on it until the next lecture when I'm going to go over it very quickly. Then you should be able to do all these problems. All right, so that concludes lecture 3A, the reactions of sugars.